Additive manufacturing techniques have been used to enhance the design and fabrication for various applications. A defining feature is the complex internal geometry enabled by the printing process. However, inspecting these structures requires volumetric imaging, leading to the well-known challenge of visualizing complex geometries using 2D desktop interfaces. In this work, we present a collaborative VR environment that allows multiple users to collaborate, explore, and inspect additively manufactured parts. The environment allows users to join either in a co-located or remote space. It can be used to improve several aspects of additive manufacturing processes, ranging from data exploration and visualization to in-depth team discussion and collaboration over distance. While our aim is focused on VR users, non-VR users can also connect in spectator mode. All interactions for data exploration and inspection are synchronized in real time between users. Moreover, we followed Nielsen's heuristics approach for usability and interface guideline verification. Various features are developed and enhanced in a real-time synchronization manner. Once the users join the virtual environment, they can start exploring the environment as well as interaction techniques. They can use the virtual tablet to facilitate exploration and inspection features, such as adjusting the intensity of volumetric data obtained from X-ray CT scans. Inspection features include a cross-section plane used to view the slice of volumetric data from different angles. In this example, we used the dataset of additively manufactured octet lattice structures for inspection. To get the view from the exact axis angle, the users can use the axis slicing view to change the image slices. Box and sphere cutouts are provided with inclusive and exclusive features. With these functions, the users can explore the region of interest and inspect internal structures of the volumetric data, as well as initiate discussion with their collaborators. For synchronization, a client-server architecture is used. Based on the client's computer capabilities and network conditions, the performance of collaborative mode could be affected. However, major factors including delay, bandwidth, jitter, and packet loss were considered and optimized during the development. The users can also load and interact with 3D scanned reconstructed model of the printed part to make a comparison and gain a comprehensive insight. The experts expressed that all developed features and annotation drawing were intuitive and useful, which leads to better informed decisions, optimized process, and part quality.